Welcome to Chapter 5.1 through 5.4, Pre-Assessment, dealing with systems of equations. So we're going to have linear equations. Notice we have two linear equations right here. They're going to be given to you in different formats, meaning you should know how or recognize slope-intercept form, and that is y equals mx plus b. You should recognize standard form, and that is ax plus by equals c. And the third one is point slope form, and that is y minus y sub 1 equals m times the quantity x minus x sub 1. And all these are important. These are important because that's how we're going to plot the solutions to each of these. And that's our goal, is to graph the solutions. So we have this first equation, and that is in slope-intercept form. So we're going to plot the y-intercept, which is 3. So we go on the y-axis, and we go to 3, and then we use the slope, which is 2, which is up to right 1. Now, we can go up to right 1, but we'd be off the graph, so we can go down to left 1. Negative and negative still makes positive. And now we're going to graph that. We're going to connect those dots, and now this line represents all of the solutions to this equation. So this is every single solution, that every single relationship, coordinate that would make this a solution. We'll do this equation, has a y-intercept of -1, and it has a slope of -2. So we're going to go down to right 1, down to right 1, or up to left 1. And now we connect this dot, those dots, should I say. And we would like to see what solutions do both of these equations share. So if we take this point, that is not a solution to this, nor is it a solution to the blue one, because it's not on either of these lines. That's a really big point. Let's get a point that's a little bit smaller. So if we take this point right here, well, that's a solution to the green one, but not the blue one, because it's not on the blue line. And if we took this point, well, that's a solution to this bottom equation, but not the green one, because it's not on the green. So when we move here to this point is on the green and the blue, so it shares a solution. So that is the solution to the system. It is the point that is shared by both equations. That's -1, 1. And then if we wanted to check it, we take the original equation. Let's take the first equation. Y equals 2x plus 3. And we plug in these values. The y value is 1. The x value is -1. And we get 1 equals -2 plus 3. 1 equals 1. And it works out. And this is checked, different from another aspect that we've done where we get a number equaling a number. So let's use the second equation. Y equals -2x minus 1. We're still checking. We're checking this point, this solution, whether it's correct. We plug in the x value in for x. We plug in the y value in for y. 1 equals 2 minus 1. 1 equals 1. And that checks also. So now I know that my solution to the system, or the point that both of these equations share, is -1, 1. So now we can do it a little bit faster and more efficient. We'll take this, we go and use it. It is in slope-intercept form, so we make a dot at the y-intercept, which is -1. We use the slope, which is -3/1, down 3, right 1, or up 3, left 1. We connect them. Let's change that color. Whoops. That's pretty good right there. And let's graph the bottom one. Has a y-intercept of 4 and a slope of 2. So up 2, right 1, I'm off the graph, so I'll go down 2, left 1. Down 2, left 1. And let's, oh yeah, blue was good. And we notice that they intersect at this point right here. And that point is -1, 2. And I'm going to check because it takes only a minute. So I'm going to check the first equation, y equals -3x minus 1. My y value is 2. My x value is -1. 2 equals 3 minus 1. 2 equals 2. And we know that this point is on this line. When it checks and it comes out true, we know this point is a solution to this. I'm going to check the second equation. Second equation is y equals 2x plus 4. My y value is 2. My x value is -1. 2 equals -2 plus 4. 2 equals 2. And that checks also. So I know this solution is correct. So what you're seeing is there's no reason for you to hand in an assessment on Thursday that isn't 100% correct. Everybody should be getting hundreds. Now look at this. This is a little bit tricky. So what's weird about this equation is that there's only one variable. So we know one variable is either going to be horizontal or vertical. And we know when there's one variable, it goes through the y-axis at -3. So it goes through the y-axis at -3. So I'm going to make a line. Sorry. So it's a horizontal line. Whoops. I got a couple mistakes there. There you go. So that is the solutions, all the solutions to this equation. Now we'll do this one. This is in standard form. So remember, standard form, we're going to find the x and y intercepts by covering up. If we want to find the x-intercept, we are going to cover up the y value. So we are going to cover up this y value. And so we get 3x equals -18. Let's divide by -3. And we find out that my x-intercept equals -6. 3 divided by -18. Divide both sides by 3. And we get x equals -6. When I want to find the y-intercept, we cover up the x term. And we divide both sides by -2. And that tells me y-intercept equals +9. And that is called the cover-up method. So those are the 2 points. This is not the point -6, 9. This is the point -6, 0 and 0, 9. So we'll plot those. -6, 0 and 0, 9 takes me there. Let's graph that. Connect those 2 dots. And now we want to see where does it intersect. Let's move that a little bit. Move that over, move that that over. And now we can connect those dots and draw. And where do we intersect? We intersect down here, right here. So that coordinate, that point is, the point is -8, comma, -3. And we check it. So we're going to check those, check equation 1, which is y equals -3. We're going to input the y value. The y value is -3, and that works. Let's check the second equation. 3x minus 2y equals -18. We're going to plug in -8 for x. We're going to plug in -3 for y, and we will simplify. 3 times -8 is -24. -2 times -3 is +6. -24 plus 6 is -18. And that solution checks out. This is my answer to my system. That's the only point that these two equations share. Again, we have standard form, so we can find the x and y intercepts. Does it remember? No, it does not. So we'll use the cover-up method. We'll cover up the y value, and we'll divide both sides by 2, and the x-intercept equals -1. And then we'll cover up the x value to look for the y-intercept, and we'll divide both sides by -1, and we get a y-intercept of +2. And now we'll use this same box. We'll find the x-intercept. We'll cover up the y value, and we're going to divide both sides by 4, so we get x equals -6. And then we'll cover up the x term, and we'll divide both sides by 3, and we get the y-intercept equals -8. So nice and easy, very efficient, nice and quick when it's in standard form. So I'm going to plot these 2 points, -1 on the x-axis. This is -1 on the x-axis, 2 on the y-axis. And we are going to connect those dots. And these are all the solutions for that first equation that is in standard form. Now we're going to take this equation. This has an x-intercept of -6. This has a y-intercept of -8. And we're going to connect those dots. Not bad, not bad. Slightly off. Ooh. All right, so herein lies the problem. Yikes. That's tough. So is my graphing off or are my numbers off? Oh, now I'm going to check. X-intercept -1. So that's at -1. That's okay. It could maybe, let's move this a little bit. This can be a little bit better because it has a slope of 2. So we can move those a little bit better. So that might be a little bit more accurate drawing. And notice it's coming and moving a little bit closer to that intersecting point. So when you get that situation, you can use the slope. It's up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. And you want to make sure that this line is going through those points, down 2, left 1, down 2, left 1. So I tightened up my graphing a little bit. And now I see that the point of intersection is there. And that looks a little bit cleaner and better. Let's put arrows on there just for purposes. That is -3, -4. So now we're going to check it. That ensures that we're doing it correctly, that our alleged point is correct. So we'll check the first equation. 2x minus y equals -2. My x value is -3. My y value is -4. 2 times -3 is -6. The opposite of -4 is +4. -6 plus 4 is -2. So that checks out. Let's do the second equation. 4x plus 3y equals -24. Let's plug in our x value, plug in our y value, and simplify. -12. This is going to be -12 also. -12 and -12 is -24. And yes, that checks out. So I know my solution is -3, -4. All right, now, this is not in a system. That's not any of the linear formats, nor is this one. This is not a linear format, so I'm going to convert. So I'm going to rearrange. I'm going to rearrange it to some formula that is, I'm going to put this in slope-intercept form. I'm going to get y by itself. So I'm going to move the 5x. I'm going to move the 3. And I get 5x minus 3 equals y, which can be written as y equals 5x minus 3. So let's graph that. That's at 3 and a slope of 5, so I would go up 5, right 1, but I would run out of space, so I'm going to go down 5. 1, 2, 3, 4, 5, left 1. And it doesn't provide me very much space. So I'm going to have to really rely on my accuracy here. And this might sort of be off. This is going to be very, I only have 2 points, so I have to be very careful. So now I'm going to look at this second equation. The second equation is -1 minus x equals -y. I'm going to multiply everything by -1. So if I multiply that, this, and this, all 3 things, I get 1 plus x equals y. I'm going to rewrite that as y equals x plus 1. I have a y-intercept of 1 and a slope of 1. So up 1, right 1, or down 1, left 1. Ooh, that does not look fun. I can't believe they're making me graph this one. Yikes. Down 1, right? Slope of 1, up 1, right 1. Y-intercept of 1. Did I do that correctly? Multiplied everything by -1. I rewrote it correctly. Yep. All right. This is going to be a doozy. Well, all right. Maybe I think I know what it is. It's not great, but I'm going to take a gander on what that is. I think this point of intersection is going to be -1/2, comma 1/2. I'm going to suppose that that is -1/2, up 1/2. So let's check. Let's use these both equations, and let's check. I'm going to check equation 1. Equation 1 again is 0 equals -5x plus y plus 3. And I'm going to plug in -1/2 for my x value. And I'm going to plug in 1/2 for my y value. That doesn't, maybe. This is going to give, no, that can't be. What did I do wrong? Did I do something wrong? Let's check it. Because this is going to give me positive. That's going to be positive. That'll be like, I don't know, that's going to be too much. It's going to be like 7 or something, and 7 doesn't equal 0. So Mr. Mac made a mistake. I added the 5x. I minus the 3. 5x minus, I see where I made my mistake. 5x minus 3, Mr. Mac. Boop. That should be in black. Silly, but because I wrote and because I show my work. So let's move this down to -3. And my slope is 5, so we're going to go up 1, 2, 3, 4, 5, right 1. Okay, we see. That's good. So we made one little boo-boo, but we were able to find it. So my point of intersection is not that, but it's good. We checked it and it wasn't working out. So when we checked, notice it didn't work. So we went back and checked our work. We didn't disregard that our check wasn't working. So my point that I think is the solution is 1, 2. So now I'm going to check, still going to check 1, 2, 1, 2, and now we get -5 plus 2 plus 3. -5 plus 2 is -3 plus 3. And yes, 0 equals 0. It checks with equation 1. Let's check equation 2. Equation 2 is 1 minus x equals -y. We're going to plug in 1 for x, and we're going to plug in 2 for y. Well, I must have made a mistake. Is the equation, it's -1. Sorry, -1 minus x. Mr. Max making a couple mistakes tonight. That's that. And -2 equals -2, and it works. So this is my solution, no, even though I tried to make mistakes multiple times. All right. Last one, graphing. This is not in any form. I'm going to put it in standard form. We have x equals -4, y equals well, am I tired? Is that what it is? Maybe. It was a little bit of a long day. I'm going to move the 4y over. I'm going to add 4y to get x plus 4y equals -8. And that gives me standard form. So my x-intercept is going to equal -8. And my y-intercept is going to equal -2. So -8. Ooh, yikes. All right, well, they didn't want to work on that. That's not good. So, all right, let's change that because I can't graph that out there. I mean, I guess I could. I could move it over and kind of think that it's -6, -7, -8. So I can put a point there. That's estimating, which isn't great. And a y-intercept of -2. Let's see if we can get away with this. Hey, that's not bad right there. It was almost. Okay, we'll try that. Let's give it a shot. We'll see if this will work. And let's look at the second equation. Second equation is -2y equals -x minus 2. We'll divide everything by -2, giving me y equals 1/2 x plus 1. So my y-intercept is 1, and my slope is up 1, right 2, up 1, right 2. Let's connect those dots. Oh, wow, that was tight. Look at that. Bam, on the money. Nice. Not bad, if I say so. Not bad. So that is the point of intersection, and that is -4, -1. So let's check our equations. Checking x, first equation is x equals -4y minus 8. Plugging in -4 for x, -1 for y. -4 equals 4 minus 8. -4 equals -4. That checks out. And my other equation is Negative 2y equals negative x minus 2. Plugging in negative 1 for y and negative 4 for x. That gives me positive 2. That gives me 4 minus 2. 2 equals 2, and that checks out. So negative 4, 1 is my solution. All right, those are 6 problems that we had different types of linear formats, so we needed to know how to pull out the information in order to graph it on a coordinate plane, and then we looked to see where it intersected. Problem 7 says solve each system, you must use substitution. Okay, we have to use the substitution method. So when we use substitution, we're looking for a variable or a term that is isolated. So we have y that is equaling a value of x. So I'm going to take that and I'm going to plug it in for the y. I'm going to substitute it in for y. Instead of writing y, we're going to write 4x plus 17. So we're going to rewrite this equation, negative 3x plus 3, and instead of writing y, we're going to write 4x plus 17. So all we did was replace this equivalency. These are balanced. These are the same. When you say y, you really mean 4x plus 17. So instead of saying y, we say 4x plus 17, and then we will finish that bottom equation equals 24. And now we'll simplify. Negative 3x. And the benefit is we had x's and y's here. We had x's and y's. And notice when we substitute, we only have x's. So that's 12x. That's going to be 51 equals 24. Let's simplify before moving things. This is 9x plus 51 equals 24. We'll move the constant, giving me 9x equals. These signs are different. I'll take the smaller from the larger. 51 from 24, 24 from 51. That gives me 27. We'll divide by 9, and x equals 3. That is the value, the x value that both of these equations share. Now, if I want to find the other one, I'm going to plug in. I need to find my y value. I found the x part of the coordinate. I know that the solution has an x value of 3, and now I have to find this y value. I'm going to use these equations, so I'm going to plug it back into this first equation, x equaling 3. So y equals 29. So I have both my x and y solution, 29. Now I get to check to see. I already know that I've sort of checked because I've put my input of 3 and I have my output of 29. So I know that 3 and 29 already work for this equation. So I need to check with this other equation, with the second equation, the negative 3x plus 3y equals 24. And so we're going to plug in 3 for x, and we're going to plug in 29 for y. Something tells me I made a mistake because that's going to be a huge number. So let's see. Did I forget a negative? Duh. Negative 27, negative 3, negative 12. So notice I'm getting crazy answers. That wasn't going to work. So I should understand that I'm going in the wrong direction. And here's multiple times where my checking has found a mistake that I would have submitted as an answer. So this is extremely valuable checking. And we have to stop and go back and check our work. And we found our mistakes each of the times too. So that's very, very important and nice. And it shows that it works. So Negative 12 plus 17 is actually 5. So my solution is really 3 comma 5, not 29. 3 comma 5. And now we're going to plug those values in for X and Y. Silly Mr. Mac. Well, it is 8 o'clock. I went to the gym, did some nice sauna, and that doesn't work either. What am I doing? Oh, negative. I forgot the negative multiple times. It's because it's not written very clear. Negative. Negative. I'm not paying attention to my work. I'm getting very frustrated with my work because I keep making mistakes, but it's taking a little bit more time to do this problem, but the time invested is coming and it's checking properly. So I am making major mistakes, but I'm catching them and I am coming up. I am certain that is the right answer now. All right, here we go. Substitution. We're looking for the variable that is isolated. We have y that is isolated in terms of x. So we're going to substitute that value in for y, where we see y. So we will replace it. Instead of writing negative 2x minus 5 times y, we're going to substitute 8x minus 12 in for y. And let's see if Mr. Mac cannot make a mistake on this one. I'm going to try my hardest to pay attention to all of this. So negative 2x, we're going to distribute, makes negative 40x. Distribute makes positive 60 equals negative 24. We're going to combine like terms. Plus 60 equals negative 24. We're going to subtract 60 from both sides. Negative 42x equals negative 84. Divide by negative 42. And x equals positive 2. I'm going to go back and check all of my negatives, make sure I'm correct. That looks pretty good. I'm going to solve using this second equation in order to find my y value. This is my x value. So I know my solution is going to be 2 comma something. So I got to find my y value first. 8x minus 12, y equals 8 times 2 minus 12, 16 minus 12, y equals 4. So I think my solution is 2 comma 4. I'm going to check. So I'm going to check with equation number 1. Negative 2x minus 5y equals negative 24. Plugging in 2 for x, plugging in 4 for y, and simplifying the left side. Negative 4 minus 20, negative 24 equals negative 24. That checks out. I didn't make any mistakes. Yay! All right. Number 9. We're not even halfway. It's going to be a long one. We're going to substitute. We're going to take this value for y, and we're going to substitute it into the y value down here. So instead of writing y, we're going to write negative 7x plus 19 equals x plus 3. I'd like to take a little something. I don't know if you didn't mean to close down. I'm going to take something if you hear it each time that it wobbles. Hear that? That's driving me crazy. So I'm going to put something underneath the table. And you will not hear that bouncing sound. Mr. Mac's OCD. It's all good. Let's move the 7x. We have to move the variables first. 19 equals 8x plus 3. Let's minus 3. We get 16 equals 8x. Divide by 8. Divide by 8. 2 equals x. That's my x value. and I'm going to use, I used the bottom equation, so I will use equation number 1 to find, I thought I had it. Oh, now it's the other side also. Both of them are wiggly. I gotta find more paper. I have more paper, more envelopes, lots of envelopes on my desk. Now it doesn't move either way. Yay. All right, sorry. Let's plug in the x value, which is 2 plus 19. Y equals negative 14 plus 9. Y equals 5. So I think my solution is 2, 5. I'm going to use equation number 2 to check. I'm going to check with equation number 2. Equation number 2 was y equals x plus 3. My y value is 5. My x value is 2. And 5 equals 5. So I am confident that 2, 5 is my solution. Still got to use substitution. That's fine. I'm going to take this y value in terms of x. I'm going to place it in for this y value. And instead of writing y, I'm going to write negative 4x plus 16 equals 8x minus 20. I'm going to move my variables first. Gives me 16 equals 12x minus 20. Add 20. I get 36 equals 12x. Divide by 12. 3 equals x. I have the x value. I'm going to take my, which equation? I use the bottom equation, so I will use the first equation. Y equals negative 4x plus 16. I'm going to put that x value of 3 in there to find out what my y value would be. Negative 12 plus 16, y equals 4. So I think my point of intersection is 3, 4. I will use the second equation to check. Check using the second equation. Y equals 8x minus 20. Y value is 4. X value is 3. Wow. Doing the math in my head already. And 4 equals 24 minus 20. 4 equals 4. My solution checked out. 3, 4. I still have to use substitution. Notice it's not set up for substitution. It's actually set up for elimination. But the directions say, read the directions. The directions say you must use substitution. So I need to manipulate this equation. It is 6x plus y equals negative 8. So I'm going to subtract 6x and I'm going to solve for a variable y equals negative 6x minus 8. And now I'm going to use substitution. I've got y isolated. I've got it in terms of x. So where I see y in the other equation, I'm going to take this and I'm going to substitute it in. Be careful of this negative though. This is tricky in that manner. You have negative 4x minus the y value. And that y value is negative 6x minus 8 equals 6. So be careful here. We have to distribute this negative into both of the terms. Negative 4x plus 6x plus 8 equals 6. Simplify. 2x plus 8 equals 6 minus 8 minus 8. 2x equals negative 2. Divide by 2. X equals negative 1. So I think my coordinate, my solution is that. I'm going to use this equation here to find y equals negative 6x minus 8. I'm going to plug in negative 1 for x, which gives me 6 minus 8, which is negative 2. So I think my solution is -1, -2. And I'm going to I used that to find my y. So I'm going to use the top equation to check. I'm going to check. And that top equation is 6x plus y. 6x plus y equals -8, I think is what it was. Ooh, that's this one, sorry. That's that equation. I got to use this equation, sorry. I'm going to check using the second equation. So I'm going to use actually -4x minus y equals 6. And we're going to plug in -1 for x. And we're going to plug in -2 for y. That's 4 plus 2 equals 6. 6 equals 6. And it checks out. So this is my solution. Still using substitution. I still need to solve for a variable. I'm going to take this equation, -4x plus 6y equals 6. I'm going to isolate. I'm going to move the x over. 6y equals 4x plus 6. I'm going to divide everything by 6. Y equals 2/3 x plus 1. I'm going to simplify fractions. Everybody should be simplifying fractions. And where I see a y in the other equation, I'm going to put 2/3 x plus 1. So we're going to have that second equation, -4x minus 4. Instead of writing y, we'll write 2/3 x plus 1 equals -24. -4x. We're going to distribute this. Yikes, that's going to be ugly. Minus 8/3 x, and this is -4 equals -24. All right, so this in thirds is -12/3 x minus 8/3 x minus 4 equals -24. -12 and -8 makes -20/3 x minus 4 equals -24. We're going to add the 4 over. -20/3 x equals -20. We're going to multiply by the reciprocal, -3/20. -3/20 x equals, the 20s cancel, the negatives cancel to give me a +3. That wasn't too bad. And now, to find my y value, I use this equation. Y equals 2/3 times 3 plus 1. Y equals 3 in the denominator, 3 in the numerator. So y equals 3. So my solution is going to be 3, 3. And we'll check using the left equation. We've already used, which one did we use? We used this one. So we use the bottom one. We'll check the bottom. We're going to check using -4x minus 4y. -4x minus 4y equals -24. -24. So let's plug in those values. 3, 3. Looks very similar to a problem we did earlier. Checks out. This is my solution. 3, 3. Now we have to use elimination. So we are going to add them together. These are two balanced equations. We're going to add up their columns. We're going to add up this column because they're aligned. They must be aligned, meaning they have to have the same format. X, Y equals your constant. So very important to remember, equations must be aligned. and must be the same. X and Y need to be on the left side, equaling the constant on the right. So if we add these columns, 2x, negative 4x makes negative 2x, negative 8y and positive 8y, their coefficients are opposite of each other, so they're going to cancel. And then we get 6. 18 minus and negative 12 is 6. Divide by negative 2. X equals negative 3. We can take either of the equations. I'm going to take the first equation, 2x minus 8y equals 18, and we'll plug in my x value in order to solve for my y value. Negative 6 minus 8y equals 18, add 6. Negative 8y equals 24, divide by negative 8. Y equals negative 3. So I think my point is negative 3 comma negative 3. I'm going to check with the other equation. Using the other equation, I'm going to check negative 4x plus 8y equals negative 12. Negative 3 for x. Negative 3 for y. This gives me positive 12 minus 24 equals negative 12, and negative 12 equals negative 12. So that means negative 3 is correct. Elimination, does it work for elimination? Yeah. Notice the y's, they have opposite coefficients. So if they have opposite coefficients, I know that that's going to get rid of one of the variables. And when I can eliminate one of the variables, I can solve for the other variable. So that gives me 17x. These cancel, equal 51. Let's divide by 17. Divide by 17. X equals 3. We use either equation. It doesn't matter. 9x minus 10y equals 27. We'll plug in 3 for x. 27 minus 10y equals 27. Minus 27. Negative 10y equals 0. Divide by negative 10. Y equals 0. So I have the supposed point 3 comma 0. And I'll check using the other equation. Check using equation number 2. 8x plus 10y equals 24. 3 in for x. 0 for y. 24 plus 0 equals 24. 24 equals 24. Yes, it does. This solution is correct. Elimination, these still cancel. This is good. We like it. Let's use the highlighter. We'll add this column. We'll add this column. And we'll add this column. This gives me negative 5x. These cancel to make 0. This cancels to make 0. I need to solve for x by dividing by negative 5. And x equals 0. That's a solution. We'll take one of the equations. Negative 2x plus 8y equals 8. Plugging in 0 for x. 0 plus 8y equals 8. 8y equals 8. Divide by 8. Y equals 1. I think the solution is 0, 1. Let's check using the other equation. We're checking with equation number 2, which is negative 3x minus 8y equals negative 8. Negative 3, x is 0, y is positive 1. 0 minus 8, does that equal negative 8? Negative 8 equals negative 8. That checks out. This is my solution. Now, elimination. So we're adding the columns, but what's the problem here? They don't cancel. So we can't use addition just yet. We're going to have to manipulate this equation a little bit. We're going to have to change it by multiplying it by a proportion. So I'm going to move this out of the way. That's number 16. We'll put that up there. And so which variable do I want to cancel? Well, I like y. The reason why I like y better than x is our signs are at least opposite. So if I multiply by positive 2, that's good for me. So if I multiply everything by positive 2, I get negative 18x minus 8y equals negative 58. You have to multiply everything by that 2. Don't forget, multiply everything by 2. This equation we're just going to bring over. We don't need to manipulate it. It's negative 18x. It's plus 8y, and it's 22. So if we add these columns, that's negative 36x. These cancel, equal negative 36. We'll divide by negative 36, divide by negative 36. X equals positive 1. So I have my x value. I'm going to use the other equation. Negative 18x plus 8y equals 22. Negative 18, I have 1 for x. That's negative 18 plus 8y equals 22. Let's add 18. 8y equals 40. Divide by 8. Y equals 5. So I think my solution is 1, 5. I use the bottom equation. I'll check using the first equation. Negative 9x minus 4y equals negative 29. I have 1 for x. I have 5 for y. Negative 9 minus 20. And yes, negative 29 equals negative 29. So 1, 5 is my solution. These do not cancel, and I'm going to have to actually multiply both of these equations. Let's move that 17 up to the top, because no number that I multiply by 4 is ever going to give me 5. No number multiplied by 4 is going to give me a negative 6. So I'm going to use the x's because I could have used the y's, but I'm still going to do the x's. So 4 and 6, I like a multiple of 12, right? 12 is a common multiple. So 2 times negative 6 would give me 12, and 3 times 4x would give me positive 12. So I'm going to multiply 2 times negative 6x, which is negative 12x, 2 times 5y, which is 10y, and 2 times negative 14, which is negative 28. I'm going to multiply everything in this equation by 3. That's 12x, that's minus 12y, and that is 1848. I think that's correct. Is that correct? 3 times 6 is 18, carry the 1. Yeah. And now we'll add the columns. The x's cancel. I'm left with negative 2y equals, I think that's 20. Divide by negative 2. Y equals negative 10. I'm going to use either equation. Let's use the bottom one. 4x minus 4y equals 16. We're going to plug in negative 10 for y. 4x plus 40 equals 16. Let's subtract 40 from both sides. 4x equals negative 24. Divide by 4. And we get x equals negative 6. So the point that I think is the solution is negative 6, negative 10. I use the bottom one, so I'll use the top to check. Check using the top equation, negative 6x plus 5y equals negative 14, negative 6x. My x value is negative 6. My y value is negative 10. That's 36 minus 50 equals negative 14. 36 minus 50 is negative 14 equals negative 14. Let's go. Checks. Good. And I think this is the last one. Now, notice it is not aligned. You must align the equations. Two equations. So what do I want that format to be? Well, I've got x here, y, and my constant, so I'll keep that. That's nothing wrong with that. Negative 36x equals 9y minus 8. Now I do have to move this, so I got to move the y over. I'm going to add the y over. That gives me negative 20x plus 10 equals 5x, 5y, that's a y. Bad handwriting. And I'm going to move the constant over because the constant is on the right side with the y, so I'll subtract 10 from both sides. Negative 20x equals 5y minus 10. Good, so I'll write that. Negative 20x equals 5y minus 10. Now I got to deal with the variables. Which one do I want to cancel? So, that's not fun. I guess I'll get rid of the y's. So I'm going to multiply the top one by negative 5 and the bottom one by positive 9. That's going to give me a common multiple, but I got to multiply everything. So that's going to give me 180x. 5 times 36 is 180. Negative times negative is positive. 9y times negative 5 is negative 45y. And negative 8 times negative 5 is positive 40. I'm going to multiply that. That is negative 180x equals, that's positive 45y, and that is negative 90. This makes 0, this makes 0, and this makes negative 50. 0 equal negative 50. Notice what happened here. Both variables canceled out. Both variables canceled. When they cancel, it's either going to be no solution or infinite many solutions. So it's either going to be no solution. That's if it's false. That's if my number statement is false, or it's going to be infinitely many solutions. And that's when it's true. When my number statement is true. That's when, not after plugging in values, this is when we're solving for, we're using elimination, and this is a false statement. 0 does not equal negative 50, so my answer is no solution. That's a very unique situation, okay? When we used elimination and we eliminated both variables. All right, that's it. That was probably an hour to do 18 problems, explaining every single one of them and checking every single answer. So not bad. Good luck.